So there seems to be some confusion around a virtual machine and a physical machine as it relates to a cloud infrastructure. So let's go ahead and just kind of briefly go over what we mean when we're talking about cloud and cloud infrastructures and how a cloud relates and is sold. There are components within a cloud environment that you need in order to make the cloud work. And one of those components, primary components, whoops-a-daisy, one of those primary components is a server, right? It's from the server that we receive compute power. So we're going to need that compute power, which of course the primary compute power is your processor. We also have RAM and cache and other things that are built onto this board to provide compute power. But for right now, let's just focus on the virtual machines within the physical machine. So let's start by talking about what is actually in that machine. And over the years, we have had different things kind of happen to our physical machines. And these I'm drawing here are the processors themselves. So this is a quad processing server, Within this server, there are four physical CPUs. These are chips that are CPUs. Okay, so we're going to draw a line here and say CPU. Okay, so these are four CPUs that are within this box. Now, just a few years ago, that would have been enough for us, right? We would have stopped there and said this is a quad processing machine, right? So many of you may be familiar with this term quad or dual processing machines, referred to the physical CPU. Now, a few years back, we started saying, okay, we have the physical CPU. Now we're going to have cores within that physical CPU. So again, we're going to draw out here on the screen here the physical CPU. All right, so gold, right? And within there, we're going to have cores. And let's draw that out with maybe red here. And so we're going to have four cores within here. All right, so this again is the physical, the CPU right here. This is the CPU chip. All right, and then within it here in the gold, this section here, these are the cores. Okay, so this is a single CPU, right, with four cores. Okay, so we're just kind of, this is very basic, lots of ways to explain this. We're going to kind of wrap this back into why this is important to cloud technology. So now we understand, right? We've got the processors themselves, the physical core processors, right? Represented here. I'm going to highlight them again real quick. These are the CPUs themselves, okay? The processors. Built within those are cores. That's an R, by the way, not a V. They're not coves, they're cores. All right? And they're built, and this represents a single CPU. So within this processor chip, we have four cores. Within those cores, typically in a cloud environment, we put what we call virtual CPUs. Okay? And those are really called better use a different color there. Sorry about that. vCPUs. Okay, so a virtual CPU. And dependent upon the hypervisor that you use, you're going to have an equation that says X cores equal X virtual CPUs. Okay? So for example, I may have one core here. Remember, this is one physical CPU. I have four cores, and inside of this core I have four cores in this single physical CPU chip. All right, I hate to keep going back, but I want to make sure we're clear here. And within here, we have multiple virtual CPUs built within those cores. Now, dependent upon the hypervisor, you're going to get somewhere, generally speaking, 5 to 10 virtual CPUs per core. Okay? So however it breaks it up, and you're going to do that, right? And so you're going to say right now, so that's kind of how the calculation goes. So X amount of virtual CPUs per core. And by the way, it's usually not, let's say they chose 10, so this physical chip would support, right? Say it with me, 40 virtual CPUs. So we're going to still have to assign RAM. So usually the factor that the limiting factor is not necessarily the number of CPUs, for example, 10 virtual CPUs per core. The limiting factor is usually the hypervisor has the max virtual CPUs per physical box. Okay? Physical server. Oops, there's an H there. I knew that looked weird. Per physical server. Okay? So, for example, in a Red Hat environment, typically best practice is 160 virtual CPUs equal one physical server. Okay, so if you look at that and you say 160 virtual CPUs equal that, and you said I'm going to have 10 virtual CPUs per chip, and I've got per core, and I've got 4 cores, right? Then, and I have 10 virtual CPUs per core, so this is 10, 10, 10, 10. So 4 virtual CPUs equal 1 physical CPU, right? 40. Then I can say that each of these are 40, 40, 40, and 40. Yes, and remember those are virtual CPUs, 40 virtual CPUs. Now this box equals 160 virtual CPUs. And then the next thing you have to worry about, of course, is RAM. So you're going to have to say to yourself, how big will this physical server, how much physical RAM will it hold? Well, let's say that it holds 320 gigabytes of RAM. That means, on average, you could have 160 VMs that are configured as 1 virtual CPU and 1 gigabyte of RAM. So now, if you look at this, it's pretty simple math, right? So that means if I wanted 2 virtual CPUs as my base for this physical box, I would say 2 virtual CPUs with 2 gigs of RAM each. All right? So now my count, if I did this equation, my count actually would be 5 virtual CPUs per core. Now, I know that's a lot of information, and I've drawn a lot of stuff on here, and please review the video again. And you have my email address. If for some reason you have a question, feel free to contact me. This is kind of how virtual CPUs work, related to physical CPUs that are all related. Remember, all of this supports the cloud, because everything that runs within the cloud are physical components that we're used to having within our environments.